Okay, so now that you understand the Ricardian trade model, we need to go back to production possibilities curves and opportunity costs because I purposefully didn't explain the entire picture with production possibilities curves and opportunity costs when I went over them the first time because you didn't need them for the Ricardian model. In the Ricardian model, you always had a production possibilities curve that that looked like a straight line, that looked something like this. So you always had a straight line, and so you had a special kind of technology there in that model that made the math a lot easier and a lot less confusing. So I went ahead and presented the production possibilities curve and opportunity cost when you had a constant opportunity cost. And we're going to go see how this all changes in a second. But I just want to kind of give you a picture of where you were and what we're changing now. So production possibilities curves don't always need to have a constant opportunity cost, and we're going to go see what happens when they don't. So to start off with, I want to define what I mean by constant opportunity cost. So what I mean by that is, let's say that this was just good y and good x, just to keep things simple. Sorry, that x is super sloppy, and good x. So to produce one more unit of good x, let's just say that this line is y is equal to, let's see, 1, 2, 3, 4, 5. So y is equal to 5 minus x. So 1, 2, 3, 4, and 5. So every single time that you wanted to increase your production of x by 1, you had to decrease your production of y by 1. So the opportunity cost of 1x is equal to 1y. And that was the same all the way across. If you were here at point A and you wanted to go to point B, that cost you 1y. If you wanted to go from point B to point C, that cost you 1y to gain 1x. If you wanted to go from point C to point D, you had to give up 1y to gain 1x, and so on and so forth. So I hope that that makes clear to you that when you have a constant opportunity cost, when the opportunity cost of producing 1x is always equal to, I should put is always equal to 1y, then you have a straight line. And another way to see this is that the slope of this line is constant. The derivative, for those of you that are into calculus, the derivative is just -1. So every single time that you want to increase x by 1, you have to decrease y by 1. And that's exactly what the derivative here says. So if you have constant opportunity costs, or if you have a technology that displays a constant opportunity cost, or constant returns to scale is another way to say that, and we'll talk about that, you're going to have a production possibilities curve that is linear. So what happens if you don't have a constant opportunity cost? And what is the situation that gives rise to that? Well, the situation that gives rise to that is a situation where as you produce more x, so as you produce more x, it gets harder and harder. It gets harder and harder and harder to continue to produce it, to continue to produce more x. So let's think of an example. Well, a great example in my mind is studying. If you're studying for the first hour, you can cram a lot of knowledge into your brain and get a really good grade off of just that first hours of studying. But then as you get into hour number 5 and hour number 6 and hour number 7 and it's getting late, you're in the library, you've had a couple cups of coffee, your brain is kind of fried, that 8th or 9th hour of studying, you really don't learn much. So as you study more and more, as you produce more and more x, it gets harder and harder to continue to study, to continue to cram stuff into your brain. And so this is a realistic model for a lot of industries, and the model for trade that we're going to go talk about in a couple videos from now also bases itself on this idea. So I wanted to introduce this first before we go ahead and get into there. So this concept that as you produce more and more of something, it gets harder and harder. That's normally referred to as an industry that has diminishing marginal returns. And that means that as you keep producing more and more, literally that it costs more and more to continue to produce the same amount. So just the inverse of what I was saying. And that's also called having decreasing marginal productivity. I've heard all of these terms used interchangeably, and that's the same thing as increasing opportunity cost in this specific example. And so now we're going to get down to this specific example. So this production possibilities curve that I have drawn here is the graph of y is equal to 4 minus x squared. So what this says is if you produce 0x, you can go ahead and produce 4y, and that's point A. So then when you produce 1x, you have 4 minus 1 squared, and you can go ahead and produce, this is the line, this is 3. You can go ahead and produce 3y. So the opportunity cost of the first y, and you're going to see why it's important to make this distinction in a second, of the first y is equal to 1x. Because going down here, you only had to decrease from 4 to 3 to produce that first x. But now we're going to go ahead and see that if to go from B to C, you're still only going to produce one more x. X is going from 1 to 2 here. But you're going to have to get rid of 3y. You're going to have to get rid of 3y. So the opportunity cost of the second x, and I'm just using x because it's what we're used to putting on this axis, but good x could be sugar, it could be soda, it could be coffee, I don't know, it could be whatever you wanted it to be, but I'm just using good x to keep it very simple to reference back to this graph here. So the opportunity cost of the second good x, oh sorry, I flipped this entire thing up here. Let me just go ahead and erase that for a second. So I hope that you caught that as I was going along, but the opportunity cost of the first x is equal to 1y. I just flipped that around. So the opportunity cost of the second x is equal to 3y. Because of this, we have to get rid, to go from point B to point C, we have to go ahead and get rid of 3y. We have to sacrifice 3y, going from y is equal to 3 to y is equal to 0, to produce that second x. So as we can see, the opportunity cost here is not constant. The opportunity cost is not constant. And the opportunity cost depends on which number of x we are producing. So to produce the first x, we only have to sacrifice 1y. But to produce the second x, we have to go ahead and sacrifice 3 of them. So 1 and 3. And so this comes about because of something like the studying example that I was talking about. So maybe this is your grade in, let's say that y is your grade in biology and your x is your grade in econ. I keep on going back to these two classes. I have no idea why. But so let's say that it only takes you 1 hour to go and get, let's make 1 a C in econ. So it only takes you 1 hour to get there, and to do that you sacrifice going from an A to a B in bio to get a C in econ. But then to study this last amount, to go all the way over here, and let's say that this is to get an A, you have to study a lot. And so you have to give up a bunch of the time that you would be spending studying for bio to go ahead and study for econ. Because it gets harder and harder to keep on studying econ, the later and later it gets and the more tired and tired you get of it. The more of these videos that you have been watching. So I hope that that makes the concept of increasing opportunity cost more clear. It's a very elusive concept, and it's going to get even more tricky in the next video. But I think that this is a good place to stop, because the next part of this video is going to go into calculus and explaining how the derivative is related to opportunity cost in this diagram. And so I'm going to stop here. We'll come back with the calculus in the next video, and if you have any questions, don't hesitate to ask, and I'll see you there.